Hi guys, welcome to our 36th webinar. The month of May has started and I'm sure that quite a few of you are going to plan to take the test in the next 2 months. So, well, exciting times ahead. Please do keep in mind that in the last month of your practice, just before your test, you do check out a lot of official questions so that you're very comfortable, the official practice questions of all the three sections, that you're very comfortable with the language of the official questions. Yeah. Now, do keep in mind that the practice tests that I'm creating currently, they are based on the official format. So, of course, they're a step ahead in difficulty, but they incorporate all the traps of the official questions, and they also test you on, advanced applications of the concepts that we have discussed. So, do use those also in your practice in the last month. They are going to be extremely helpful. So then let's get started with today's webinar. Today we're going to discuss some data sufficiency questions. Some of you have shared these questions with us, and you're having a problem with understanding the solution that is given. And I think quite a few of these questions are from GMAT Club. Some of these questions are official. So let's discuss how we will solve it. Let's discuss what should come to our mind when we look at these questions, and how to solve them in limited amount of time. Right? We'll try and solve each one of them within, let's say, 1.5 minutes. That is the aim. Right? So let's see how we're going to do that. I'll share my screen with you. I'll tell you exactly what I'm thinking when I'm reading the question. Yeah. So machines K, M, and N, each working alone at its constant rate, produce one widget in X, Y, and 2 minutes respectively. So they're saying machine K produces one widget in X minutes, machine M produces one widget in Y minutes, and machine N produces one widget in 2 minutes. So I have concrete data only for machine N. What does it say? It says one widget in 2 minutes, right? So let me just write down in 2 minutes. I don't have to do it in the exam. I'm just writing it down for us right now, that this is what I'm thinking. Okay, so N produces one widget in 2 minutes. The only concrete data in the first sentence. If machines K, M, and N work simultaneously at their respective constant rates, does it take them less than 1 hour to produce a total of 50 widgets? So essentially, it is asking us whether their combined rate of K, M, and N is more than 50 widgets per hour, right? If they are going to take less than 1 hour to produce 50 widgets, that means their rate is more than 50 widgets per hour. They're asking, are they producing more than 50 widgets every hour, right? Okay, now the only thing that I do know is that N produces one widget in 2 minutes, so in an hour. So since we're asking, they're asking us about the hour, I'll say, okay, one widget in 2 minutes. That means in 1 hour, that is in 60 minutes, it is producing how many widgets? 30 widgets. Is that okay? Right. All right. So I know that N alone is producing 30 widgets in 1 hour. My question is that does it take them less than 1 hour to produce a total of 50 widgets, which means that are they producing 50 widgets or more in an hour? Yeah. Is their rate more than 50 widgets per hour? So that is my question, that in 1 hour, are they producing, 50, more than 50 widgets? All right. So X is less than 1.5. Look at the two statements. X is less than 1.5. Now, this is the number of minutes taken by K and M to produce one widget. Yeah, this is less than 1.5 minutes and this is less than 1.2 minutes. Now, I don't have concrete data even when I am being given these numbers, because I mean, I don't even know whether it is 1 minute or whether it is 30 seconds, less than 1.5. Absolutely doesn't give me anything, doesn't give me any clarity, right? But then notice here that, N takes 2 minutes to produce one widget, yeah? And it is able to produce 30 widgets in an hour. If K is taking less than 2 minutes, if K is taking less than, in fact, 1.5 minutes to produce one widget, can I say that it will definitely make more than 30 widgets in an hour? Why? Because N is taking 2 minutes for one widget. So N is slower. K is taking for one widget less than 1.5 minutes. Let me say it is 1 minute, or let me say it is 1.2 minutes. It doesn't matter, whatever. But it is taking less time to do the same work. That means K is faster. So if N is producing 30 widgets in 1 hour, then how many is K producing? I don't know how many is K producing, but I can say that it is certainly producing more than 30 widgets in 1 hour. K is faster. So then, if I'm looking at just my statement 1 over here, I know K is producing more than 30 in an hour and N is producing 30. So then total, I know in an hour, the two of them, K and N together, are producing more than 60 widgets in an hour, right? So now when N is also included, then they'll produce even more, isn't it? So in any case, K, M, and N together are definitely producing more than 50 widgets every hour. So to make 50 widgets, it is going to take them less than 1 hour. So my answer is going to be yes over here. It is a definite yes over here. Do I need to do any calculations over here? No, absolutely not. I don't have to assume values. I don't have to think of anything. The only thing I have to think of over here is that, hey, my x is less than 1.5, which means that K is taking less time than N to produce every widget. Yeah. So K is faster. Then in an hour, it is producing more than 30. So then automatically, it is total number of widgets will be more than 60, right? So then this alone is sufficient. Okay. What about Y? Y is less than 1.2. This is telling me that M is even faster than K. N is taking 2 minutes for one widget. K is take even faster. I mean, just assuming, yeah. I don't know. It could be, X actual value could be 1 also, and this Y actual value could be 1.1. That's fine. But in any case, it is saying that Y is taking less than 1.2 minutes per widget. So this is your M is also definitely producing more than 30 widgets per hour. But now I'm comparing my M with N, right? If I'm looking at statement 2 alone. So I'm comparing my M with N, I'm ignoring K. N takes 2 minutes for one widget and M takes less than 1.2 minutes. So it's much faster than N. Right? So if N makes 30, then now M is going to make more than 30. Definitely. So now my K and M together are going to make more than 60. And then when I add N also, of course, it's going to be much more, right? So then this alone is enough as well. Which means this alone is enough as well. So my answer over here is going to be B. Each statement alone is sufficient. Do I have to worry about any calculation? Do I have to think about anything? No, I don't have to. In any case, look, I don't have any value for X and I don't have any value of Y, right? So then I don't have their actual rates. I just have it's less than 1.5. But that is enough to tell me that they are faster than N. And certainly it is, it's enough to tell me that they will produce more than 50 widgets in an hour, or they'll take less than 1 hour to make 50 widgets, right? This is an official question, and it is one of the difficult official questions. But then if you understand rates very well, then it'll take you what, a minute to answer this, right? It is one of the difficult official questions. Yeah. And not as per OG categorization or anything. It is as per GMAT Club. It is one of the difficult questions, right? But are we clear over here? Does it make sense? Khalil drove 120 kilometers in a certain amount of time. What was his average speed? Okay, so 120. So I have been given that distance is 120 kilometers and I'm not given the time. What was his average speed in kilometers per hour during this time? So we need the time for which he drove, and then we'll get the average speed. Obviously, we know average speed is total distance upon total time taken. Okay. Statement 1. If Khalil had driven at an average speed that was 5 kilometers per hour faster, his driving time would have been reduced by 20 minutes. Okay. So, if you've gone through the content of time speed distance, you would know that we do use ratios a lot in time speed distance, but when we are given an increase in speed or an increase in time, so basically S or S plus 5, for example, then we cannot use ratios over there, right? Because when S, let's say, increases by 5, it's not a definite ratio increase. It's not a definite percentage increase. What percentage increase it is depends on what the value of S is, right? So there we cannot use ratios. So here I see that I will have to take a variable and then solve the question. All right, let me also take a look at statement 2 once, just in case if that is easier, I will come back to statement 1. Statement 2 says, if Khalil had driven at an average speed that was 25% faster, his driving time would have been reduced by 20%. Okay, I really like this because it talks about increase in terms of percentages. So I know I can use ratios that I can, I think I can get my answer very quickly. So let me evaluate this first. Of course, we'll have to evaluate one also separately, but let me evaluate two first. So I look at 2 and I say if Khalil had driven at an average speed that was 25% faster, 25% faster means that the ratio of his new speed is to old speed would be 5:4, right? 25% faster means 125 by 100, which is 5:4. Now, if I know that if the ratio of his speeds was 5:4, then the ratio of the time taken, this is the ratio of the speeds, right? The ratio of the time taken new is to old is going to be 4:5. I know that, right? Because the distance traveled is the same. If the speed was 25% more, then, the ratio was 5:4, then the ratio of time would have been the inverse of that, 4:5. So I'm given his driving time would have been reduced by 20%. Look, this is the old time, 5, and it has gone to 4 on the ratio scale. So it actually has reduced by 20%. Now, here is the point that this statement gives me no information. This is something I can also say. It is nothing relevant to my data given in the question. It has nothing to do with what is given to me in the question. Do you understand that? This is something that I can say about any speed in any scenario. I can say that if the average speed increases by 25%, then the time taken reduces by 20%. This is something I know automatically. You don't have to tell me. This is not new information that you're giving me, right? Look, the moment you say that if the average speed increases by 25%, I myself can tell you that, okay, then the ratio of time will become 4/5, 4:5. And then that means there's a reduction of 20% in the time taken. Let's say if time taken in the old scenario was 5 minutes, this would become 4 minutes, right? So it's a reduction of 1 minute in 5 minutes, which is a 20% reduction. I can also tell you that. So you're not giving me any information in this statement, which means that certainly this statement is not sufficient. And in fact, it's not giving me any information. So now, one, I know that my answer is not B, right? This alone is certainly not sufficient. It's not telling me anything. I also know now that my answer is not D. I also know now that my answer is not C. Do I see that? Why? Because if both of them together, I mean, there is no way I'll require both these statements together because this statement tells me absolutely nothing, right? So then, if this statement gives me the answer, then the answer is going to be just A. Or if this doesn't give me, then the answer is going to be E. So I have eliminated 3 options out of the 5 options by seeing that this statement gives me absolutely nothing. All right, let me look at the first statement now. If Khalil had driven at an average speed that was 5 kilometers per hour faster. So now, as I said, since there is an addition of speed, S and S plus 5, I'll need to take a variable. So I'll have to say that speed, let's say, is equal to S, initial speed, original speed. And I hate doing that. But then once in a while, in some GMAT questions, you would require to take, a variable, yeah, once in a while. Rarely, okay. Now, if the speed becomes S plus 5, then his driving time would have been reduced by 20 minutes. That is 1/3 of an hour, right? Because, we're talking about his average speed in kilometers per hour, so we should convert everything to hour. So what this means is that, let's say 120 upon S is the time taken, right? When his speed was S. When his speed increased, then what happened? Then time taken was 120 upon S plus 5. Yeah. And this gave me, this difference is equal to what? 20 minutes. 20 minutes means 1 upon 3 hours. Of course, I want everything in kilometers per hour. So I've converted it into hours. Yeah. Now, this is the equation that I have to solve to get whether, to get the value of S, right? I need the speed, right? What is his average speed? I'm assuming his average speed is S. So I say 120 by S, this gives me the time taken in the original case. When his speed increased by 5, time taken reduced, time taken this is smaller. So this time taken minus this time taken is equal to 1 by 3. Right? This is how I make my equation. I hope this is clear. Yeah. Okay, now look, I can do one thing. I can say I can bring 3 over here. I can say this is 360 upon s minus 360 upon s plus 5 is equal to 1. And we have discussed in the curriculum as well that when we have equations like this, we can try and plug in some values. We can try to find the value. We can try to find which value works for it. Right? We can do that. But it can get really complicated because 360 has so many factors. So let's say I don't want to do that, and at that time in the rush of things, it's very hard for me to join the various to, break it down into its prime factorization and join the various factors to see which two factors are going to work out for this, right? Of course, I don't have the options over here. So what, and I know that when I solve this, I'll get a quadratic. Now, usually it's fine. I mean, I'll get a quadratic. There is one worry that I have. What if both the roots of the quadratic are same? Yeah. Or what if I get two different roots of the quadratic and both work, right? So just looking at this equation, I cannot say whether I'll get a single value of s or I'll get multiple values of s, right? So, or two values essentially, of course. So then I'll do a little bit of calculation over here. So what do? I say, okay, so, let me put 360 over here. Then I say s plus 5 minus s upon s into s plus 5. So I'll just take it to the other side. I'll call it s square plus 5s. Right? This becomes the denominator. So I've just taken it to the other side to reduce the calculation essentially. So then this gets cancelled. Now I have s square. Okay, this looks like a 5. S square plus 5s. Yeah. And now this 360 into 5 is going to go over there. So it becomes minus 360 into 5 is equal to 0. Yeah. I'm not even going to calculate this right now. Yeah. Look, what do I have? I have that the product of the two roots is negative and the sum of the roots is positive, right? So this tells me that one root is positive and one is negative, whatever they are. I don't care. Yeah, I don't want to spend my time looking for them. But I know that this is going to be something of the form, let's say s plus 20 and s minus 25. Something like this is equal to 0. I don't know what it is. Yeah, I'm not going to try to find it. But because the product of the roots is negative, I know that one root is positive and the other root is negative, right? Both cannot be positive, both cannot be negative, right? Then only this is going to give me a proper value for S. Yeah, I'm not saying the value is 25. I'm not calculating. I'm just giving you an example, illustration that something like this would happen, right? So this will give me a positive value for s. This will give me s is equal to minus 20. And since we're talking about speed, it makes absolutely no sense, right? So then when I look at this equation, I know that I'm going to have one value for s only. Yeah. And since I'm going to have only one viable value for s, that is why this statement alone is sufficient. Yeah. And that is why my answer over here is A. As we said, statement 2, of course, has no relevance because it gives me no information as such at all. Right? Does this make sense? Let me know if you have any queries. Yeah. So yes, in case this term was negative, the plus 5s, yeah, let's say this was a minus, and let's say, something minus something, and this was, let's say, a plus something. Then I would get factors both of the form s minus a, where a is positive, and s minus b, right? Because the sum is negative and the product is positive, which means it is a negative into a negative. So then I would get relevant values, both relevant values, A as well as B, right? Of course, if I have to check if this is a perfect square. This is not a perfect square, but in case I get a perfect square, then I know that there is only one value that I have for S. right? So I have to do that evaluation of the quadratic, but then I don't have to solve it actually. In fact, if I, get down to solving it, it's going to take me a hell lot of time trying to figure out those factors over here, because 360 is a number which has a lot of small factors, right? And this is an official question. Please do keep in mind, they don't expect you to find it either, right? So yeah, so exactly. So when you say that you're falling short on time on quant, we're not falling, and this is going to be in DI now. You're not going to, you don't fall short on time. You need to understand how things work so that you don't do unnecessary calculations, you don't spend time unnecessarily, right? And this you